This lesson is going to introduce us to the concept of normal distribution. Now, normal distribution problems are problems that deal with probability, and these probability problems are always going to give us the mean as well as the standard deviation. Now, if you recall, mean is always given to us with the Greek letter mu, and standard deviation is always given to us with the Greek letter sigma. Let's look at this example so that we can understand exactly the type of problems that we're looking at. The problem reads, the mean clotting time of blood is 7.45 seconds with a standard deviation of 3.6 seconds. What is the probability that an individual's clotting time will be less than 7 seconds? So this is what I'm talking about. We are given the mean. Here we go. We're given the mean, which is 7.45 seconds. So mu is 7.45. And we're given the standard deviation, which is 3.6 seconds. So sigma is 3.6. And the question asks, what is the probability that the clotting time will be less than 7 seconds? So notice this is an important point that we're going to come back to in a few minutes. Some problems are going to say less than. Some problems are going to ask for greater than, and some problems might ask for in between certain areas. So let's see how we're going to approach this kind of problem. So the idea here is we want to look at the area under a normal curve. This picture here that I've put up is called a normal curve or a bell-shaped curve. And we are going to say that the area beneath it, the total area beneath this curve is always 1. So that's the first thing that we need to know, that the total area is always 1. And here's what we're going to do. We are going to assume that our midline is mu, right? This is our symmetric line, and this is mu, which means that if the total area is 1, everything to the left of it is going to be 50%, and everything to the right of it will be 50% as well, because mu splits your graph directly in half. And what sigma is going to be a certain distance here from mu. This is going to be our sigma. So that's our standard deviation, and we have our mu as well. The idea here is that sigma, the standard deviation, is a standard unit away from mu. But what if the problem that we are looking at, the particular number that we're looking for, is not that standard deviation? In this example, we're talking about 7 seconds, where 3.6 seconds would be 1 unit away from u. So what we want to do is we want to find what is called the z-score. And the z-score is going to tell us how many standard deviations away from mu our number is. So here is our formula for z-score. Z is equal to x minus mu over sigma. Now remember, mu and sigma are our mean and standard deviation, and x is what we are looking for in this particular problem. So sometimes we are going to end up with z-scores that are positive. And if our z-scores are positive, it means they are to the right of mu on our graph. So here we would have a positive z-score. And if our z-score ends up being negative, that means that we are to the left of mu on our graph. Once you have your z-score, you're going to move over to your handy-dandy chart, and every problem is going to have a chart along with it. And the chart is going to give you the area under the curve up to that particular point. So if this is our z-score here, the area up to this point from the left up to this point, that is what you will get from your chart. Now the great thing is you don't have to memorize the chart, it will be given to you, but you do have to memorize the formula for your z-score. So what we might see, another example, if your z-score is here, the area on the chart that's going to be given to you will be this area up to here. So the next thing you need to figure out is the problem looking for the probability less than that z-score or greater than that z-score. If it is less than that z-score, The area is exactly what you want. The question is how do you find this area here if it is a greater than z-score? Well, it's very simple. If we know that the entire area is going to be 1 underneath this curve, then whatever area we found, our A, that's from our chart, if we subtract it from 1, it will give us the rest of this area in here. So just in this particular example here, the idea is if we know that our mean, here's our mu, is 7.45, and we want to know the probability of it being less than 7 seconds, our z-score, since 7 is less than 7.5, our z-score is going to be negative. It's going to be somewhere out here, and we're going to want to know what is this area under the curve. So again, these probability problems are asking you what is the area under the normal curve. Okay, so to recap, these are our steps. First, you're going to draw a normal curve and label mu. Remember, mu and sigma are going to be given to you. Next, you're going to find your z-score. Remember, your z-score is always your x minus mu over sigma, and put it on the graph. It's going to be to the right of you if it's a positive z-score. It's going to be to the left of mu if it's a negative z-score. Next, you're going to shade in the area that the problem is looking for. This is going to help you very visually understand, are we looking for less than z, the probability less than z occurring, or are we looking for the probability greater than z occurring? So you've got to shade in the appropriate region. Once we do that, we can then go ahead and look at the z-score on your chart. Now remember, the chart is going to be given to you. It is not something that you need to memorize. And you'll see in the examples, the chart is very long and lengthy and complicated. So you're going to look up the z-score on your chart and you're going to say, okay, this is the area we are talking about. And then you're going to determine if that is the area. If it's less than, that will be the answer, whatever area you found. If it's greater than, you're going to have to subtract that area from 100 to find the answer that the problem is looking for.